You may be wondering how to simplify a square root or a cube root of a monomial expression. I'm going to show you how to do this using the prime factorization method. So, in this one example, the square root of 28, let's go ahead and think of factors for 28. It could be not including 1, so you don't want to include 1, you want to include other factors. So I have 2 and 14. 3 doesn't go into it, but 4 and 7 definitely do. Okay, so I'm going to go ahead and take the 4 because I know that 4 is a perfect square. I'm going to go ahead and separate my problem into 4 and 7. Well, I know that 4 is made up of 2 times 2. And remember that the two numbers that come off of the number above should multiply to get this number. 7 is a prime number. It has no factors other than 1 and 7. So I know that, for example, this would be equivalent to this. Okay, so when you have 2 of the same number, or let's say a pair, go ahead and circle that. One of the pair gets to go out. Anything that's left over, I go ahead and I stick maybe a box around it or a squiggly or something. That reminds me that that's going to go here, and this would be my final answer right here. Okay, so let's go ahead and move on. What about if I added a monomial expression including variables? So here we go. So I'm going to take our same 28a squared b. Now, one of the properties of radicals says that I can actually split up anything underneath the radical sign. So I'm going to go ahead and do that. So I'm going to make this into root of 28 and root of a squared b. I could even go as far as to separate the a squared from the b and do b in its own problem, but I'm going to let them here right now. We already know from the previous problem that the two factors that are easiest to use are 4 and 7. 4 breaks down into 2 times 2, and 7 is prime, so we can't do anything with that. So I'm going to go ahead and put this on kind of like a back burner. So I know that my answer, again, is 2 root 7 because I have two 2's. I circle them, and one of them gets to go out. Anything that does not have a pair has to go under the root sign. Okay, so let's do our variables the same way. Okay, obviously A has a pair, so I'm going to go ahead and circle it. One of the pair gets to go outside, whereas this B has to stay under the root sign because it is all by itself. Therefore, our final answer for this would be 2A root 7B. And that would be your final answer to this. Now, you might be asking, okay, what do I do if there's a cube root? Okay, so let's do that one as well. I'm going to change the numbers up just so that I can go ahead and use a cube root. So how about we use the number 32? 32, you've got 2 and 16. You've got 3, 4, and 8. That's about it. Now, out of these, which is a perfect cube? Well, that's 8. So I'm going to use that, and don't need to forget to put that right there. So let's go ahead and break it down by 4 and 8. Okay, again, 2 times 2 makes up 4. 8 is 4 times 2. This 4 here breaks down into 2 times 2. Okay, so as you can see, I have 1, 2, 3, 4, 5 2's that actually multiply together eventually to make up my 32. Okay, now instead of looking for pairs, we're looking for a trio of numbers. So for example, I'm looking to have a group of 3 numbers. before I can pull one outside of the root side. So now I have this. So again, a trio of numbers, only one gets to go out. And what you're left with is 2 2s. Now, the third root of 2 2s is going to be harder to put together, therefore, it's going to be irrational, basically. So what you're going to do now is you're going to say 2 root 3. The property of radicals also says that anything underneath the radical sign can be multiplied. So that would be your final answer. Let's do one last problem with a cube root as well as variables. So I'm going to keep our 32, but I'm going to add some letters. A squared, b cubed, c to the 4th. Okay. Again, remember one of the properties of radicals says that I can separate all of this. So let's go ahead and do that. From the previous problem, we know that 2 good factors of 32 are 4 and 8, because 8 is a perfect cube. Again, you're going to break it down until you get down to a prime number. This is called prime factorization. Okay, so as you can see, I have 1, 2. So I have 1, 2, 3, 4, 5 2s. I need a group of 3 because I'm doing a cube root. So here we go. I have one group of 3, so I know that there's going to be 1, 2 outside of the root side. Don't forget to say that it's a cube root. What I have left over is 4, because it's 2 times 2. Now, so let's go ahead and let's tackle our variables. Okay, I'm going to put the cube root of the 2 cube root of 4 on the back burner, and let's tackle our variables. So we have a squared, b cubed, c fourth. Now, some people like to separate them completely. I don't, just because you're going to eventually just write them out and circle anyway. So there's no use to do that. However, whichever way works for you, do it. So I'm going to write out all the letters as many times as the exponent says. Okay, as you can see, I have 2 A's, 3 B's, and 4 C's. Okay, so now I'm looking for a group of 3. I'm going to use a different color ink, and I know I have one group of 3 C's. I have 1 C left over. I have one group of 3 B's, nothing left over, and the A's are squared, therefore there's not 3 to circle. So here we go. From before, you know that we have our 2 root 4 sitting there, ready to bring down. 2 cube root of 4. Okay, how many of these have a complete circle of 3? Remember, if you have a cube root, you're circling 3 of the same letter, and you're bringing one out. Okay, so I know that 1B can come out, so I'm going to rewrite this. And I also know that 1C can come out. Now, I'm going to rewrite this problem. I know that my 4 from above is still there, okay? What do I have left over? I have A, and I have a C. Of course, I can actually simplify the AA and make it into 4A squared C. And that's all for today. Thanks for learning with me. Bye.